Hello everyone, I am Incharaj, studying at Sri Venkateshwara College of Engineering, Bangalore. Today I want to discuss about a mini project report on 4-bit up counter to reset 1011. There are 4 members in our team: Bindushri CJ, Bindushri M, Dikshita YN, Inchara KR. I want to discuss about this is our certificate of mini project entitled 4-bit up counter to reset 1011 carried out by Bindushri CJ, Bindushri M, Dikshita Y and Inchara KR. Students of Sri Venkateshwara College of Engineering have satisfactorily completed the mini project as project based assignment in data structure and applications. Guided by Bama Ma'am, Assistant Professor CSE Bangalore. Department vision. This is the department vision to be a school of excellence in computing for holistic education and research. There are 3 department missions: academic achievement in computer science and engineering through student-centered creative teaching learning, qualified faculty members, assessment and effective usage of ICT. Mission 2. Establish a center of excellence in various verticals of computer science and engineering to encourage collaborative research and industry-institute interaction. Program outcomes. These are the program outcomes. Engineering knowledge. Apply the knowledge of mathematics, science, engineering fundamentals, and engineering specialization to the solution of complex engineering problems. Problem analysis. Identify, formulate, review, research, literature, and analyze complex engineering problems, reaching substantiated conclusion using first principle of mathematics, natural science, and engineering science. Design or development of solution. Design solution for complex engineering problem and design system components or processes that meets the specified needs with appropriate consideration for the public health and safety. Conduct an investigation of complex problem. The 5 program outcomes are moderate tools usage, 6th one are the engineering and society, the environment and sustainability, ethics, individual and teamwork, communication. These are all the program outcomes. Program educational objectives. Knowledge. Computer science and engineering graduates will have professional and ethical interior disciplinary domains, providing innovative and sustainable solutions using modern tools. Skills, attitude. These are the program specific outcomes. The program specific outcomes are ability to adapt quickly for random domain, interact with diverse group of individuals and entrepreneur in the society and global setting. The program specific outcomes too is ability to visualize the operation of existing and future of software application. This is the abstract. The project details the design and implementation of an XS3 to binary code converter, focusing on efficiently converting XS3 coded decimal numbers into binary representation. The commonly used digital system offers advantages such as error detection and correction, making it a valuable component in various applications. The convert system is designed using combination all circuits translate XS3 inputs into binary outputs. The methodology involves a thorough analysis of XS3 code properties, including its representation of decimal digits and its relationship with binary encoding. By understanding these properties, asymmetric conversions processing developed. Practicing testing further validates the converter performance, evaluating factors such as conversion speed and resource utilization. By measuring these metrics, the efficiency of the converted assessed provided practical applications in real-world scenarios. Overall, this project contributes in the advancement of digital logic design techniques by providing a systematic approach to XS3 to binary conversion. The converter systems represented Herein supports various applications requiring XS3 code processing, including digital arithmetic operations and communication protocols. Additionally, the project serves as the foundation for future research and development in the field of digital logic design and implementation. These are the in a table. What are the table of contents of these reports are? First one is introduction of the project. After, what are the required objectives of this project? After, future scope, code and output, conclusion, and what are the reference we used to make this project successful. First I explain what are the reference I used to success this project of 4-bit up counter project. There are few books that we might find useful for the 4-bit up counter project. A great a book writer, Roger L. Turkin, they wrote Digital Electronics Principle and Applications. This book is very used to make this project. The next one, we use modern, we read so many books to this project. The second one is Modern Digital Electronics by R.P. Jain. The next one is Digital Designs Principle and Practices by John F. Buckerley. And next book we read Fundamental of Digital Logic with Verilog Design by Stephen Brown and Zukro Barnesic. These books cover various aspects of digital circuits, include counters and sequential logic. And we saw some videos also to successful this project. The links are uploaded in this project. Future scope of this project is, when it comes to the future scope of a 4-bit up counter with a reset of 1011, there are a few possibilities to consider. First one is expandability. You can explore the option of expanding the counter to a higher number of bits, such as an 8-bit or even a 16-bit counter. This would allow for counting larger values and more complex application. Second one is integration. You could integrate the up counter with the digital circuits or microcontroller to create more advanced system. For example, you could use it as a part of larger control system or in combination with other modules for data processing. Timing and synchronization. You might explore incorporating features like clock synchronization, adjustable counting speed, or ability to count in different modes. Fourth one is output control. Consider adding features to control the output of the counter, such as enabling or disabling specific bits or incorporating additional logic to generate specific pattern or sequence. These are the just a few ideas to get me started. The possibilities for expanding and enhancing a 4-bit up counter are vast. It ultimately depends on your specific project's requirement and goals. I hope this gives some inspiration for the future scope of our up counter. Thank you for watching this video. Next part is continued by my friend Bindushri CJ. She explained how to run the program and how to we get the output of the program. She's explained more about the program and project details. I over to Bindushri CJ. Thank you.
Hello everyone, I am Bindushri CJ, second year BE student at Sri Venkateshwara College of Engineering. Today I am going to discuss about a mini project based on a digital design and computer organization, that is a 4-bit up counter to reset 1011. That is a 4-bit up counter to reset 1011. Aim: we implement the 4-bit up counter to reset 1011. Theory: a 4-bit up counter is a digital circuit that counts in binary form 0000 to 1111. That the counter increments its value by 1 on each clock cycle. To design a 4-bit up counter that resets at the count 1011 decimal 11, you need to add a reset condition. When the counter reaches the specific count, each square bracket represents a flip-flop, a memory element that stores a bit. The Q0, Q1, and Q2 and Q3 outputs represent the 4 bits of the counter. The clock input triggers the counter to increment of each rising edge. To implement the reset condition, at 1011, you can use the additional logic to detect when the counter reaches its this state and assert the reset signal. The reset signal will force the counter back to 0000. The reset condition is activated when the counter reaches the state 1011. The exact logic for this reset depends on the implementation method, such as using AND gates, XOR gates, or the combinational logic. The reset signal forces the counter back to 0000, restarting the counting sequences. And is a circuit diagram. Advantage, and we discuss about advantages and disadvantages of 4-bit up counter as to reset at 1011. Designing a 4-bit up counter with a reset condition at the count of 1011 can have various advantages depending on specific requirements of a given application. Here are some potential advantages. Limited count range. The counter resets at 1011, limiting its range to 1200 to 1011. These can be advantages in applications where you can need a specific count range, and you can ensure that the counter resets at a particular point to start a new counting sequence. Synchronization with other devices. If other components or devices in a system operate based on a count sequence and they are synchronized with the other counter having a reset specific counter, and help in coordinating actions or events within the system. Sequence control. The reset condition at 1011 allows for a controlled sequence of events. It can be useful in applications where specific actions or operations need to occur after a certain number of counts, and resetting at 1011 helps in defining the end of a sequence. Customized functionality. The reset condition provides a degree of customization to counters functionality depending on the applications. Customized functionality. To reset, the condition provides a degree of customization to the counters functionality, depending on the customer's application requirement. The counter can be configured to reset to res, to reset requirements. The counter can be configured to reset easily when needed, allowing for flexibility in the overall system design. Reduced complexity. Having a predefined reset condition simplify the design by eliminating the need for external logic to generate a reset signal. This can lead to a more straightforward and efficient implementation of the counter circuit. Fault tolerance. In some applications, having a reset condition at a specific count can provide a form of fault tolerance. The counter needs to stay within a certain range to avoid errors or undesired behavior. The reset conditions acts as a safeguard. Disadvantages of a 4-bit up counter to reset 101. While there are advantages to designing a 4-bit up counter with reset condition, the count of 1011, there are also potential disadvantages that should be considered. Limiting count range. The counter's counting range is restricted to 12 counts, so if a larger counting range is required for a particular application, the design may be limiting and not suitable for scenarios where the greater count is necessary. Interrupted sequences. Requesting Resetting at 1011 may interrupt certain counting sequences that would naturally extend beyond the point in applications where uninterrupted counting is essential. The reset condition may disrupt the desired functionality. Complex sequencing logic. In some cases, the need for a reset conditions at 1011 may introduce additional complexity to sequential logic. If reset condition is a part of larger control strategy, it might require alternate components. Increased power consumption. Depending on specific implementation, the circuitry needed to detect and respond the reset condition could contribute to increased power consumption. This is exceptionally relevant if counter spends a significant amount of time in operation. Higher circuit complexity. The specific requirement for a reset condition at 1011 may necessitate additional logic gates or components in the counter circuit. The increased complexity can impact overall design, potentially making it challenging to understand troubleshoot or maintain. Program code. We can use a module up counter with reset, input wire clock, input wire reset input, output register 3:0 count, close the bracket. If reset begin, count is less than or equal to 4B000 end, otherwise else begin. If count is double equal to 4B1011, count is less than or equal to 4B000 end, else begin, count is less than or equal to count plus 1, end module. This is the output. In output, the counter increments its a value by 1 on each clock cycle. Thank you for watching my video.